Hi and welcome to our lesson today on volumes of pyramids and cones. Now, this is a follow-on. We've already done all of the intro work for measurement. We've done the intro now. We've done some work on surface area of all sorts of different shapes. And last video was all about the volumes of prisms and cylinders. And so today we're going to do pyramids and cones. And the great thing here is that in many cases they're just formulas you need to write in your summary book or learn. I don't know, that's a great thing. Why not learn them? Life would be so much easier if we didn't have summary books. For those of you in internet land, you will be aware that we are following along here with the Cambridge Essentials textbook series. That's what I'm using to teach my kids. And for those of you who are in my lesson, you need to do that work there. But as is normal, recap. So last lesson, we've looked at how to find the volumes of prisms and cylinders, and prisms are really, really awesome. So long as you can find the area of the cross section, you can multiply it by how far back it goes, and that will give you the volume of that prism every single time. Doesn't matter what prism it is, so long as you can find the volume, or sorry, the area of that cross section, the area of that front face, whereby it will be equal all the way through. You can multiply it by how far back and it gives you the volume. Remember that your volume must be written in terms of units cubed. It must have that floaty 3 in every single answer you give. Unfortunately in exams, particularly with maths, if you don't, we knock your lots of marks off. And for cylinders, we came up that the volume was pi r squared h. How do we know that? It's still the same area of cross-section times length. If we remember, what is the area of cross-section of a cylinder? Well, we have a circle on the top. We have a circle on the bottom. So the area on the top is pi r squared, and we would multiply it by how far it is between those two circles, which in this case is h. So my formula comes to be pi r squared h. That's really, really important. Now, there are other shapes. This one, for example, is the volume of a pyramid. Now, luckily for this course, and in fact for any course, I don't have to show you why this is true. To be able to do that would make the video about 17 hours long, and you would not want to sit through 17 hours. All you need to be aware of, or what you need to know and use, is the volume of a pyramid. And in this situation, using a pyramid of height h and side length x and x, which would suggest this was a square-based pyramid, it is given by 1/3. That's literally the fraction of 1/3 times the base area. And in this situation, our base area would be x times x, which is x squared, times by the height given there. Now, this is not the slant height. Do you remember from a previous video, we talked about how slant height was awesome for surface area? Not here. We are looking for the height from the base of the triangle. So if you imagine we just saw the triangle front on, we're looking for that vertical height to be able to help us find the volume. As you can imagine, maths will try and trick you by giving you the slant height and the actual height. And I can guarantee you lots and lots of people will make mistakes. Please don't. Just remember. So here is an example. If I tell you that this is square base, so I'm going to draw those little marks on, and you've got the height of 10 centimeters, what is the volume? Remember, it is 1/3. So there's my 1/3. Area of the base. Well, because it's a square, the area is 5 times 5, or 5 squared, times by the height of 10. Doing this nice and easily, 25 times 100 is 250, and 1/3 of that is 250 over 3. Now again, I have left this here in what we call an exact value. It's a fraction. We haven't actually put down the decimals. Sometimes in exams, they will ask you to leave your answers as an exact value. Now, when it's exact, it has to be a fraction, or it has to be some form of surd, or it has to have a pi in it. If the question says round it to 2 decimal places, then I would absolutely use my CAS calculator to substitute that out and use it in. But as this is just a quick example, because these are all just formula based, I haven't done that on my CAS. Volume of the cone is another one you need to know. Now again, remember there are right cones and oblique cones. A right cone, is where my height is at right angles to my base. Here, my oblique cone, although my height is at right angles, we can actually notice that the oblique is actually just been pushed over. So, the volume of a right cone is 1/3 times base area times height. Hold on a moment, that seems very familiar. That seems to be the volume of my, what was that, pyramid. So the volume of my cone is the same as my volume of my pyramid, which is 1/3 times base area times height. And in this situation, because the base of my cone is a circle, there is my area of pi r squared. So 1/3 times pi r squared times h, which is my vertical h. Strangely, my oblique cone is exactly the same. Just because it's been pushed over doesn't change the formula. So what do we look at here? My volume is once again 1/3 times pi r squared. Why pi r squared? Because that is a circle times the height. Now again, this has to be my vertical height between the base and the highest point of my cone, not the slant height. And here's an example. I know this cone doesn't look very oblique. Let's just pretend for now it is oblique. But what would, oh no. Here's an example, and not of an oblique cone, of just a standard cone. We know that it has a diameter, being very careful here, that my diameter of my circle is 10 centimeters and my height is 15 centimeters. So using my formula, and I'm going to advise you to always write your formula. Why? Well, substituting in to a formula is less likely to have errors if you have the formula there than if you're trying to remember it off the top of your head. And so what do I actually know? I have got 1/3 times pi times the radius squared. Don't be tricked. They gave you the diameter was equal to 10, so the radius was equal to 5, times by my height, and my height was 15. Now you're probably going to say, hold on a moment, what's this slash through the 3? Well, I'll just write it out again. Pi times 5 squared times 15. Now 1/3 is the same as dividing by 3. And while I can divide by 3 at the very, very end of my calculation, because multiplication can be moved around, so 2 times 3 is the same as 3 times 2, I can actually do 1/3 of 15. And when I work out 1/3 of anything, it's just the same as dividing by 3. So what I'm really doing is saying, well, let's get rid of the third and divide the 15 by 3, and that gives me 5. And that's where that little 5 came from. So my sum then became pi times 5 squared times 5, which was pi times 25 times 5, which is pi times 125. And again, I've left my answer as an exact value. If the question said to round to 2 decimal places, I'd put that into my CAS calculator, I'd press equals, and it would come out with my value, as long as I'm in the right mode. And that's what I would put in, rounded to 2 decimal places. Really, guys, I hate to tell you this, there's really not much to this exercise other than those 2 formulas. 1/3 times base area times height, be it a cone or a pyramid. Thanks so much for watching. I look forward to seeing you next time.
It's been so great having you watch this video that I'd like to see you again and again and again. Wow, we could make some amazing maths together. So, if you'd like to, and you'd like to be updated as to when I upload new videos, why not subscribe by clicking the button on the right. Otherwise, if you want to click and see another video created for this type of series, then click the video on the left. All right, well, you have an awesome day, and I look forward to see you again.